Hello and welcome to A-Level Math. This is the second video in the series Circles. In the first video, we discussed the very basic concept of circle and the equation of a circle, which was x minus h the whole squared plus y minus k the whole squared is equal to r squared, where h comma k denotes the center of a circle. So now let's extend that topic a bit further by finding out what the general equation of a circle looks like and how from that equation we can compare our previous equation. So let me explain you what I mean by that. So the general equation of a circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So this is the general equation of a circle. What I mean is that suppose you take the previous equation at hand, that x minus h the whole squared plus y minus k the whole squared is equal to r squared, and you open up the squares, then you will see that you have x squared minus 2hx plus h squared. So if you open up all the squares, you will see that you have some x square, you have some y square, you have some x terms, you have some y terms, and then you have some constants. So basically, these two equations are none but kind of representing the same thing, which is a circle. So this equation is a circle, uh, and not just that, every equation, if we write anything x squared plus y squared and put any value of g and f, say for example, if you write x squared plus y squared plus 8x minus 4y plus 5 is equal to 0. So all those things represent a circle. So we need to know how these two equations, this equation x squared plus y squared and entire thing, this equation and our previous equation x minus h the whole squared plus y minus k the whole squared is equal to r squared, how these two equations are related and in which cases do we need to interchange their form. So in most of these examples which we are going to look into this tutorial, we will see how we can switch between these two equations and how it can help us to solve the problems. Okay, let me expand what I mean a bit further. So suppose this is the equation x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now let me try to write this equation down in the original form. That means x minus h the whole square plus y minus k the whole square is equal to r square. So I'll try to convert this equation into that form. Let's see how to do this. So what I do, I take these x terms together and these y terms together. So what I have is, oops, sorry. So x squared plus 2gx together, and then plus y squared plus 2fy together, and then plus c is equal to 0. Now I need to complete a square over here. So in order to complete a square, I see that one g square is missing, and similarly to complete a square over here, one f squared is missing. So I include these two terms. So I write x squared plus 2gx plus g squared plus y squared plus 2fy plus f squared, and then I again subtract these two terms because I cannot just add them. It's not something that I can borrow and without returning. So if I'm borrowing something, I must return it. So g squared and f squared I have added and subtracted, so it doesn't make any difference, and plus c is equal to 0. Now you see that this is a whole squared. I can write this as x plus g the whole squared, and I can write this down as y plus f the whole squared, and then I can write down all these stuffs on the other side. So let me export them. G squared plus f squared minus c. Now if you see, we have reduced our this equation into the previous form, and I just need to make this g as minus g. So for that I need to write this as x minus minus g the whole squared plus y minus minus f the whole squared is equal to g squared plus f squared minus c. Now this is in exact same form as the equation. Okay, let me change the color of the pencil. Let's take it at blue. So the original equation was x squared, x minus h the whole squared plus y minus k the whole squared is equal to r squared. This is the equation of a circle from the previous chapter, remember? And now we have reduced this equation into this form. How come? Because if you see, if you take minus g as h and minus f to be k, then we have x minus h the whole squared plus y minus k the whole squared is equal to r squared. So you have to take this as r. So what I get is that my h is equal to minus g, my k over here is minus f, and my radius squared is g squared plus f squared minus c. So clearly, do you remember that h comma k was the center of the circle? H comma k was the center of the circle. So what do we have to take away from this entire thing is that suppose you have any equation in this form, which is a circle, and you are asked to find out the center of the circle. So it's a very easy task for you. What you need to do is just take this term 2gx. So this 2gx will give you 2g. So what you need to do, you just divide it by 2 and supply it with a negative sign. So I mean to say, just find out the value of minus g, because that will give you h. And just take this part and find out what minus f is, and then this will give you k, and h comma k will become your circle. Let me explain it to you with the help of an example so that you understand it. But first of all, let me summarize whatever we have discussed. So we have discussed that any equation of this form, x squared plus y squared plus 2gx plus 2fi plus c, represents a circle, but there are some conditions. So the condition is that the coefficient of x square and y square has to be same. So in this case, both of these are 1, but it's not necessary that both of these has to be 1. They can both be 2, they can both be 3.5, they can both be pi, they can both be log 2 or whatever. But the condition is that the coefficients of x squared and y squared has to be equal. That's the first requirement. The second requirement is that this g squared plus f squared minus c has to be positive. Why positive? Because it represents the radius squared. So if we are squaring something, it cannot be negative, right? Because it's the square quantity. The square of any number can never be negative. So g squared plus f squared minus c, because it is radius square, so it can never be negative. So this is the second point that you need to remember. If this becomes negative, that means the radius square will be negative and there will be no such circle existing. So these are the 2 points. And finally, one more thing you have to remember is that the term xy shouldn't be there. Okay, so x and y, both of these terms exist in this equation, but they don't exist together. X square, y square, 2gx, 2fyc, x and y can never occur together. So these are the 3 takeaways. So if question asks you in the examination that when do a second degree equation represent a circle, so you have to mention that when the coefficient of x square is equal to the coefficient of y square, and it doesn't contain the term xy, and also the g squared plus f squared minus c should have to be greater than 0. Okay, so these are the requirements. And then if any of those second degree equations satisfies all these 3 requirements, then the minus g comma minus f will represent the center of the circle, and root over g square plus f square minus c will be the radius, because r squared is g squared plus f squared minus c, right? So in order to find out the radius, you just need to find out the square root of that. Let's quickly take an example and understand what I mean by that. Minus g minus f must be a little confusing to you as of now, so let's make more sense out of it. So what I said is that suppose this is the equation of a circle. They have already said you that okay, this is a circle, so you don't need to verify. Of course, it's good practice to verify this. So the coefficients of x squared and y squared are both 1, so it's good. The term xy is not there, it's also good. And let's quickly find out the r squared, which is g squared plus f squared minus c. So for that, we first need to find out the values of g, f, and c. Okay, so to find out the values of g, f, and c, what we need to do, we need to compare this equation with our standard equation. So what is the standard equation? X squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So this is my standard equation. Now if you compare, you see that with x we have -6 over here, and with x we have 2g over here. So because these two equations are equal or identical, so we have 2g is equal to -6. So from here we get g is equal to -6 divided by 2 minus 3. And then this is okay. We have found out the value of g and we can put it over here. Similarly, we have to find out the value of f square. So we see that with y we have 4 over here. So 2f should be equal to 4. So I get 2f to be equal to 4, which gives me f is equal to 2. So we have found out g, we have found out f, and lastly we see that c is just -36. So c is equal to -36. We have found out the value of g, f, and c. Let's quickly put these down in here and see what happens to our r square. So r square is -3 the whole squared plus 2 the whole squared minus c, means minus of -36, gives us 9 plus 4 plus 36. 36 plus 4 is 40 plus 9 is 49. So my r turns out to be 7, because the square root of 49 is +7 or it could be -7. But remember that we are talking about radius of a circle, and radius can never be negative. That is why we only take the positive square root of 49, which is 7, and our r becomes 7 over here. So let me quickly summarize what we have. G is -3, f is 2, r is 7. So G is -3, f is 2, c is -36, and r is equal to 7. Now we are asked to find out the center of the circle. So the question says that we have an equation and we are asked to find out the center and radius. The radius part is already done. What we need to do is find out the center of the circle. So we know that center is given by -g comma -f, because that is what is equivalent to h comma k, right? We have deduced our original equation, 2x minus h whole squared plus y minus k the whole squared, etc. And then we get that h is actually -g and k is -f. So in this way, -g comma -f gives us the center of the circle. So what is -g then? -g is actually 3, because minus of -3 is 3, and -f is -2. So this is the center of the circle. Okay. Let me quickly tell you a very shortcut to find out the values of g, f, and quickly find out the center of any circle. Okay, so remember this is our answer, 3 comma -2. And now let me give you a shortcut. So it's actually not a shortcut, it's very basic common sense. So if you see the term whatever you have with -6, this represents 2g, right? So if I directly ask you, okay, tell me the center of this circle, so you can quickly find out the center by knowing that my center is -g and what I have at hand is 2g. So if I want to find out -g from 2g, then what I need to do is first of all divide this by 2. So this is 2g, and dividing it by 2 will give me g, and then just change the sign of it. So I'll find out -g directly. So because center is -g comma -f, and these things represent 2g and 2f, so a shortcut is that divide this by 2 and then change the sign. So dividing by 2 gives me -3, changing the sign gives me 3, and then dividing by 2 for this y term, dividing by 2 gives me 2, and changing the sign gives me -2. So in this way we can straight away find out the center of the circle without going into those g's and f's if it is not required. So remember this shortcut to find out the center directly from the equation: divide by 2, change the sign, that's the center. And if you want to find out the radius, then this is your c, these are -g and -f, and then you do g square plus f square minus c under root, you find out the radius. Okay, so let's take up another question. Find the equation of a circle passing through these 3 points. Okay, so let's quickly find out the equation of the circle. So how do we do that? Let's assume that, okay, let the equation of the given or the required circle be x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Now I want to find out the values of g F, and C, because these are the only three variables over here. And that is why they have given us the 3 points. Using these 3 points, I can quickly find out the values of G, F, and C. All right. So uh, we know that the circle passes through 5 comma 7, right? So let's quickly put down these values. So 5 squared plus 7 squared plus 2 times 5 times x plus 2 times 7 times sorry, uh I need to put down the value of x, not g is something that I need to find out. Sorry for that. So 2 times g times 5 plus 2 times f times 7 plus c is equal to 0. On simplification, I get 25 plus 49 plus 10g plus 14f plus c is equal to 0. On adding these two and then moving them to the other side, I get 10g plus 14f plus c is equal to, what is 45, 49 plus 25, 49, 59, 69, 74. So it is 74 minus 74, okay, because we are transporting it to the other side. Let's call this as our equation 1. So what we have got an equation in terms of G, F, and C by using just this single point. Similarly, if I use one more point, which is 6 comma 6, I will be getting one more equation in the terms of G, F, and C, and yet another equation in terms of G, F, and C by using this third point. So I'll be having three equations in three variables, and I can solve them for G, F, and C and find out the values of these three variables, and again put these values of G, F, and C in our original equation, and we will be having the equation to the circle, right? So I think I can leave this to you as an exercise. And once you have found out the equation of the circle, then it is easy for you to find out the center and the radius. The center is minus g and minus f, and radius is g squared plus f squared minus c whole inside the root. So because you already have found out the values of g, f, and c you by solving these three equations, so it will be no nothing a big task for you to find out the center and the radius. Okay, so let's move on to the next question. Show that the points 5 comma 5 and this and this and this are concyclic. So let me tell you the meaning of concyclic. Concyclic means if I say that 4 or more points are concyclic, that means that all of those points are lying on the same circle. So if I give you 4 points, 1, 2, 3, 4, and I say that these are concyclic, that means they will be all lying on the same circle. I'm so sorry for my bad diagram, but this is the meaning of that. Okay, and 3 points are always concyclic because there is always one circle that you can draw from those 3 points. Remember how you used to draw a circumcircle to a triangle? So if you follow that logic, if I give you any 3 points, except that all those 3 points are lying on the same straight line, if I give you 3 points which are not on the same straight line, suppose here, here, and here, if I give you any 3 points like that, then you can always draw a circle passing through these 3 points. How come? You just join these points and form a triangle, and then I think from your previous classes, maybe higher secondary, maybe secondary classes, that you can always construct a circumcircle on that triangle. So the circle will pass through all those 3 points. So any 3 points are always concyclic. You can always pass or make a circle using these 3 points, except for the case where all of the points lie on the same straight line. So if I give you 3 points like that, you can never make a circle out of it. Okay, but the question is whether 4 points can be concyclic or not, because if I take 3 points, I have a circle. It's not necessary the 4th point lies on the same circle or lies inside or outside the circle. So that becomes a question. Okay, so that is what they have asked us to find out. They have asked to find out, okay, whether these 4 points are lying on the same circle or not. So what we do, we first of all find out the circle passing through these 3 points. Let's ignore the 4th point completely, because I can always find out the equation of a circle passing through these 3 points using the previous method. Let's assume that our equation is x squared plus g squared plus 2gx plus 2fy plus c is equal to 0. And then I one after the other, I keep on plugging these values instead of 5,5, 6,4, and minus 2,4. And then I find out the values of, sorry, this will be y square. And then I find out the values of g, f, and c by solving three equations, which I'll be getting by putting these 3 points in succession, one after the other. So I solve these, I find out the equation of this circle. And lastly, what I need to do is that I just verify if 7 comma 1 satisfies the equation or not. So let me tell you what the answer is. So the equation to this circle is x squared plus y squared minus 4x minus 2y minus 20 is equal to 0. So on taking these 3 points, you will be finding out the equation of the circle. Now what you need to do is that you need to verify whether this 7 comma 1 lies on this circle or not. So you just put down 7 in place of x and 1 in place of y. So minus 4 times 7 minus 2 times 1 minus 20, and verify whether it is turning out to be 0 or not. That means if the LHS is equal to RHS. So 49 plus 1 minus 28 minus 2. I think, did we make a mistake over here? 7 squared plus 1 squared minus 7 times 4 minus 2 times 1 minus 20. Okay, I'm missing out minus 20 here. Okay, so 49 plus 1 is 50, minus 28 minus 2 minus 20 is minus 50. So 50 minus 50 is 0. So this point 7 comma 1 indeed lies on this circle. So we have proved that, okay, these 4 points are concyclic. And now we just need to find out the center and the radius of the circle. So what is the center? We know that for finding out the center, what is the trick? Just divide it by 2 and change the sign. So my center will be, dividing by 2 is minus 2, changing the sign is 2. And also divide by 2 and change the sign here as well. Dividing by 2 gives me minus 1, changing the sign gives me 1. So this is the center of my circle. And to find out the radius, I have minus g, I have minus f. My c is equal to minus 20. So c is minus 20. So my radius square will be g square, which is minus 2 square, f squared, which is minus 1 squared. So minus g is 2. So g will be minus 2. Similarly, minus f is 1. So f will be minus 1. So g square plus f square minus c gives me 4 plus 1 plus 20 is equal to 25. So r square is 25, means r is equal to 5. So we take only the positive value because it is the radius. And see, the answer matches. Center is 2, 1, radius is 5 units. Let's quickly take up one more question. Find the equation of the circle passing through the vertices of a triangle whose sides are represented by the equation this, this, and this. So what the question says is that they have given us a triangle, and suppose that these are the sides of the triangle. X plus y is equal to 2, 3x minus 4y is equal to 6, and x minus y is equal to 0. Now the question is asking you to find out the circle which is actually a circumcircle to this triangle. Okay, that means we have to find out a circle which passes through these 3 points, these 3 vertices. Okay, so first of all, what we need to do is just find out these vertices. And how can we do that? We just simultaneously solve these 2 equations. On solving these 2 equations, I'll be getting this vertex. On solving this and this equation, I'll be getting this vertex. And on solving this and this equation, I'll be getting this vertex. So suppose that the vertices turn out to be 1, 1, 1, minus 2, and 2, 3. I'm not doing this question fully because I want you to do it and try it out on your own. Just solve these, find out the vertices, and then we have 3 points and we need to find out the equation of the circle passing through these 3 points, and we proceed in the exact same way we did in the previous 2 questions. So yeah, and finally verify whether your answer turns out to be this or not. Right? One more question. Find out the equation of the circle whose center lies on the line x comma y 4 minus 4y is equal to 1 and is passes through these 2 points. So it's a little different from the previous three questions in the sense that in the previous three questions we were always given the 3 points from which the circle used to pass. But in this question, we are given 2 points and one extra condition. So still we can find out the equation of the circle. So let's assume that the equation of our required circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. So I know that my center over here is minus g minus f. This I know. And the question says that the center lies on this line, right? So that means my center will satisfy this equation. So that means if I put minus g in place of x and minus f in place of y, it will be satisfied. So let's do that. Minus g minus 4 times minus f is equal to 1. So I've just plugged in minus g in place of x over here and minus f in place of y over here. So I get minus g plus 4f is equal to 1. So this is the first equation, and other two equations I can get by using these 2 points. So if I put 3 in place of x and 7 in place of y, I'll getting second equation. And for this point 5 comma 5, if I put 5 in place of x and 5 in place of y, I'll be getting third equation. So I'll be having three equations again, 1, 2, and 3, and I solve them together to find out the values of g, f, and c, and then I finally get my answer. I haven't written down the answer to this question, but you can try it on your own. Find out the equation of a circle concentric with the circle 2x squared plus 2y squared minus 6x plus 8y plus 1 is equal to 0 and double of its area. So the question says that find out one circle which is concentric to this given circle. Concentric means that the two circles have the same center. Okay, so whatever is the center of this circle will be the center of my required circle as well, but the required circle will have double the area of this circle. So let's see how to proceed. So let's quickly figure out the center of the given circle. Our given circle is 2x square plus 2y square minus 6x plus 8y plus 1 plus 1 is equal to 0. Now we need to first of all write down this equation in standard form. When I say standard form, remember that we have x squared plus y squared. We don't have 2x square and 2y square or whatever. So first of all, I need to divide all these terms by 2 so that I write it in the form of standard form. So I divide each term by 2. X squared plus y squared minus 3x plus 4y plus 1 by 2 is equal to 0. I cannot divide this exactly, so I've just written 1 by 2 over here. So now this is in the standard form, because for standard form we don't need anything to be coefficient of x square and y square. We just need 1 and 1 to be the coefficients of x square and y square. That is why this step is required. And now what we need to do, we need to find out the center. So the center is, remember, half of this and then change sign. So center is half of minus 3, which is minus 3 by 2. Changing the sign is 3 by 2. So 3 by 2. And again, half of 4 is 2. Changing the sign is minus 2. So the center is 3 by 2 comma minus 2. This is my center, which represents minus g and minus f. And my c over here is half. So let me quickly find out the radius as well. My radius square is equal to g squared, means minus 3 by 2 the whole squared, plus f squared, which is 2 square, minus c. So this minus g is 3 by 2. That means g is minus 3 by 2. So that's why g squared plus f squared. So minus f is minus 2, and that is why f is 2. So g square plus f square minus c, we need to simplify this to get 9 by 4 plus 4 minus half. And then I take 4 as the LCM. So 9 plus 16 minus 2 gives me 16 plus 9 is 25, minus 2 is 23 by 4. So my r squared is turning out to be 23 by 4, and my center is 3 by 2 comma minus 2. Center is 3 by 2 comma minus 2. So center is minus 3 by 2 comma what was it, minus 2, no, it was 3 by 2 comma minus 2, and my radius squared was 23 by 4. So my radius is root over 23 by 4, or just 2, because if I need to square root the numerator and denominator, so numerator is root 23 and denominator root over 4 is just 2. So I can split the square roots on the numerator and denominator and make it right as root 23 by 2. So I've got the center, I've got the radius. Now the question says that I have to find out another circle with this same center. So 3 by 2 and minus 2, and the area should be double. So let's quickly find out the area of our required circle. So area of the given circle is what? Pi r square. So area of the given circle, is equal to pi r square, which is pi into 23 by 4. So the area of required circle is double of this, because the question says that I have to find out a circle with the center the same as this and area should be double. So area of the given circle is pi 23 by 4. So required circle is double of this, which is 2 times pi into 23 by 4, which is pi into 23 by 2, which is pi times 23 by 2. So this is the area of my required circle. So what will be its radius? So let the radius of my required circle be r1. So pi r1 square is pi into 23 by 2. Pi cancels out. R1 is equal to root over 23 by 2. So now this time it is entirely rooted, because I have 23 by 2 and none of the square roots exist. So r1 square is 23 by 2. So r1 is root over 23 by 2. This is the radius of my required circle. Okay. So I have the center, I have the radius. I just need to find out the equation of the circle, and I can just use my formula from the previous chapter, from the first video. So I know that x minus h the whole squared plus y minus k the whole squared is equal to r square is the equation of the circle with h comma k as the center and r as the radius. So I know the center 3 by 2 comma minus 2. So I just plug in the values, x minus 3 by 2 the whole square plus y minus k. So y minus minus 2 gives me y plus 2 the whole square is equal to radius of this required circle is root 23 by 2. So its square is 23 by 2. So again, squaring gives me the same thing. So this is the equation of my required circle. Hope this makes sense to you. A lot more to come about circles in the next few videos. So stay tuned and study harder, study smarter with A-level math. Thanks a lot. Bye-bye.